Welcome to Inequalities Lesson 2. Yesterday was so fun learning something new and trying something where we talked about what an inequality is. It's showing something that's less than or greater than or equal to, and how we can show that, all the answers to that on a graph. So today we're going to determine whether numbers make an inequality true. Okay? Whoops. Here we go. So let's read together our content, our learning objective, our learning target. So start at I can, ready, go. I can use substitution to determine whether a given value makes an inequality true. Okay, so just like in equations where they would say like x plus 4 equals 12, does substitute for x equals 7 and see if it makes it true. That's what we're going to do today, okay? So determine whether the given number is a solution. So let's look. Here we have our inequality. Read that out loud. X is greater than 7. So let's see. If wherever I see x, I'm going to put this number. So is 9 greater than 7? Is that true? Yes. Woo! That's it. Let's try this one. Let's read our inequality first. 3 times x plus 9 is greater than 33. And they want us to see if x equals 7, does it make it true? So let's substitute in and solve. 3x does not mean 37. It means 3 times 7 plus 9. Is it greater than 33? Let's see. What's 3 times 7? 3 times 7 is 21. Plus 9. We're asking, is it greater than 33? 21 plus 9 is 30. Is 33 greater than 33? Or is 30 greater than 33? No. So x equals 7 is not a possible solution for this inequality. Let's try this one. X plus x is less than 3 times x. So let's see if we can solve this one. Wherever I see x, I'm going to plug this in. So really I have 8 plus 8. Is it less than, asking ourselves, is it less than 3 times 8? Well, what's 8 plus 8? 16. 3 times 8? 24. Is 16 less than 24? Yes. All right, pause and try this one. Oh, welcome back. This one might have been a little tricky. Let's see. 5 to the x power is less than 11 plus 13. So wherever I see x, I'm going to substitute and use 2. So 5 to the second power is less than 11 plus 13. What's 5 to the second power? 25. If you thought 10, remember, exponents mean repeated multiplication. And what's 11 plus 13? 24. Is 25 less than 24? No. So 2 is not a solution. It would not show up on our number line for this inequality. All right, pause and try this one. Okay, we have 6 times x plus 5 is greater than or equal to 7x. For x equals 5. So wherever I see x, I'm going to substitute in and put 5. So I have 6 times 5 plus 5. Is that greater than or equal to 7 times 5? Let's see. 6 times 5 is 30. 7 times 5 is 35. Remember, we're asking, is this true? 30 plus 5 is 35. Let's read our solution. 35 is greater than or equal to 35. Is that true? Yes, because of that equal part. 35 is equal to 35. It's greater than or equal to. Let's do this one together. Let's try. Okay. X to the third power plus 7 is less than or equal to x to the second power minus 3.2. All right, wherever I see x, substitute 6 in. So then I'm going to do it over here so I have a little more space. 6 to the third power plus 7 equals, nope. See, sometimes we get in the habit of equations is less than or equal to 6 to the second power minus 3.2. Okay, so first we've got to evaluate our exponential numbers. So 6 to the second power really means 6 times 6. So we would have 36. 6 to the third power is 6 times 6 times 6 again. 6 times 3 is 18, 19, 20, 21. So we have 216 here plus 7. And we have 36 minus 3.2. Well, 216 plus 7 is what? 223. 36 minus 3.2. Let's regroup. 10 minus 2 is 8. Don't forget to bring that decimal down. 5 minus 3 is 2. And then my 30. So let's read this. 223 is less than or equal to 32 and 8/10. So 6 does not make this inequality true. All right, go ahead and pause and try this one. All right, this one would take some extra work. So wherever I see x, I'm going to substitute in 2. So 47 and 8/10 times 2 is less than 96. We're asking ourselves, is this true? So I'm going to do this work over here. 47 and 8/10 times by 2. Help me out. 2 times 8 is, say it out loud, 16. 2 times 7 is 14, plus 1 more is 15. 2 times 4 is 8, plus 1 is 9. 1 digit behind the decimal, so I need 1 digit. So we have 95 and 6/10. Is it less than 96? Yes. Barely, but still less than. All right, let's see. Determine which solutions are correct. And we would just put a little check mark here. So let's see. Let's put 6 in. 6 plus 3 is less than or equal to 8. Well, what's 6 plus 3? 6, 7, 8, 9. Is 9 less than 8? Nope. So if I were using tools like on the RISE test, oh, you can't do it. Never mind. I was going to use that strike through tool. So, okay, so that one is out. Let's try 3. Now, you could do it in your head if you want, or you can do the work. 3 plus 3 is less than or equal to 8. Well, what's 3 plus 3? Is 6. Is 6 less than or equal to 8? Yep. Okay, so now let's do 5. 5 plus 3 less than or equal to 8. Well, what's 5 plus 3? 8. Is 8 less than or equal to 8? Yes. All right, now let's substitute 8 in. 8 plus 3 less than or equal to 8? What's 8 plus 3? 8, 9, 10, 11. Is 11 less than or equal to 8? Nope. So only 3 and 5 out of this set would make it true. So you would put check marks on those ones, okay? Try this one on your own. All right. Put 10 in. 10 minus 5 is 5. Is 5 bigger than 8? Nope. Okay, put 14 in. 14 minus 5 is 9. Is 9 bigger than 8? Yes. 13.5, put that in. 13.5 minus 5. I'm going to show my work on this one. 5 minus 0 is 5. Can't do that. So I borrow 13 minus 5 is 8. Is 8.5 greater than 8? Yes. All right, now substitute 8 in. 8 minus 5 is 3. Is 3 greater than 8? Nope. Nice. If you got that right, give yourself a pat on the back. 1, 2, 3. Great job. Let's do this one together. So wherever I see x, I'm going to substitute the numbers they give me in. Okay, so for this first one, I would have 3 times 7 plus 13 is less than 44 minus 7. All right, well, what's 3 times 7? 21. What's 21 plus 13? Let's see what 34. We're asking, does 7 make this true? Well, what's 44 minus 7? 44 minus 7 would be what? 37? So is 34 less than 37? Yes, so 7 makes it true. Then I've got to erase my work or write smaller. Or if you feel comfortable, you could do it in your head. But mathematicians show their work so that they can prove that they're right. So let's try 10. 3 times 10 plus 13 is less than 44 minus 10. Okay, so 3 times 10 is 30. 30 plus 13 is 43. 44 minus 10 is what? 34. So is 43 less than 34? Nope. So that is not a solution. So let's try 13. Whoops. 3 times 13 plus 3, is it less than 44 minus 13? All right, I don't know my 13 times tables. Well, I do. Okay, 3 times 13 is 39. Plus 3 more would be 42. Is it less than? Well, 43 minus 13 would be what? 31? Nope. Those two did not make it true. Let's see. Let's try with 5. 3 times 5 plus 13. Is it less than 44 minus 5? 3 times 5 is 15. 15 plus 13 is 25, right? Yeah. 44 minus 5 would be 39. So 25 is less than 39. Is that true? Yes. I just realized I made a mistake over here. I should have added 13, not 3. So 3 times 13 is 39, right? Plus 13 more would be 52. Still does not make it true, right? Okay, now I want you to just guess and check. Let's see, what is a number that could make this true? X plus 7, and I want it to be bigger than 9. So could I put 2 in there? Well, 2 plus 7 equals 9. Does it say it could be equal to 9? So it's got to be bigger than 2. So x could equal 3. X could equal what? 4.5. X could equal 2.1. X could equal, this is a sixth grader's favorite, if it could be 10 or 100 or 1,000. You could check that to see. Anything basically bigger than 2 would make this equation or inequality true. Haha, that was a rhyme. So let's look at this one. A number, when I take 6 away from it, has to be less than or equal to 15. Okay, so what's a number that I could subtract 6 from and make it less than 15? I like to always check for 10 first just because it's easy. Is 10 minus 6 less than or equal to 15? Well, 10 minus 6 is 4. Is 4 less than or equal to 15? What else could make this true? What if I put 0? 0 minus 6 is negative 6. Negative 6, is it smaller or less than or equal to 15? Yes. Okay. Lots of different possible solutions. I'm sure you came up with one that I didn't. Go ahead and pause and see if you can come up with something for this one. All right. How many of you said, okay, 7 times something has to be smaller than 44? Oh, 1. 7 times 1 is 7. Okay. I could also have said 6. 6 times 7 is 42. I could have said 5.5. That would be smaller than 44. I could say x equals 2. X equals 0. Because, guys, I just did that whole thing backwards. I apologize. It's very important to make sure that you read the inequality symbol. I just did things for less than, but our inequality symbol is greater than. So we want to make numbers bigger than 44. So obviously 7 times 6 is not true because it'd be 42, and 42 is not bigger than 44. So what could make that true? Thanks for sticking with me. 7 times 7 is 49, and it's bigger than 44, right? 10, 8.5, 1 million. Basically anything bigger than like 6.5, 6.8. Thanks for sticking with me on that one. Haha. Sometimes you gotta read it twice. Okay, so this is one where you would take numbers from here and drag them into the boxes up here to make them true. And it once we put numbers in there, that when I put 12 in for y, it would be true. So let's just try, let's see. Something times 12, we want it less than something. So let's see, let's put 84 in here. And let's put 5 in here. Let's see, when I put 12 in, 5 times 12 is 60. 84 is greater than or equal to 60? Yeah, so that makes it true. Okay, so let's look at these. We have 3 possible numbers left, 7, 8, and 72. 84 needs to be less than this. So let's see, if I put 72 in here, and then I substitute in my 12, 72 plus 12 is 84. Uh-oh. Will that make it true? Nope. So 72 can't go there. So 72 is going to have to go here. Most of the time it will only let you use it once. If I put 84 in here, 84 plus 12 is what? 96. Is 84 less than 96? Yes. So that would be our answers. I could also have done, nope. Yep, that would be the only way. Okay, so let's talk through this one together. We want to substitute m in to make it true. So here, this one's different. This one says complete an equation and an inequality. Remember, equations only have one thing that make them true. So let's look down here. What 2 numbers, when I multiply and use 7, will work? The only thing that would work here is I could do 3 times m, 7, right? Because wherever I see m, I put 7, equals, what would make that true? 21. So let's see if we can use the rest of the numbers. A number times m, or a number times 7, has to be less than or smaller than 26. So which of these leftover numbers here would be smaller or less than 26 when I multiply by 7? 2. I could also put 1 in there. That either of those would make it true. Okay. All right, guys. We have reached the end of our lesson. Make sure that you've filled out your CAMI as we've gone through this video. And up at the top here-ish, click Submit so that it gets turned into your teacher and you get credit for participating in the lesson. And then go do the group work or the practice and the exit ticket. Best of luck. Great work. This is so fun to do something new. And we'll see you tomorrow.